So here the first lab is just user enumeration via different response. Okay, we can just open it here. So basically this is this lab is vulnerable to username enumeration and password brute force attacks. It has an account with the predictable username and password, which can be found in a following word list: candidate name and password. Yeah, we can. So what we need to do is enumerate username via different response, which can be found in the following. This is yeah, I can show you how we can do brute force using the brute force attack using the burp suite. Okay, just so we can understand how it works. We have authentication theory here, right? Something about authentication. No, we don't have. We have here. Authentication is answers one question: who are you? Verifies the user identity before granting access. Authentication comes before authorization. Okay. Yeah. It answers who are you. Authentication versus authorization. Authentication is one thing. Who are you? Authentication, what can you do? There's two different things. Authorization relates to is related to permission. Authentication is like identification. Okay. Common authentication factors, we have something you know, like password, PIN code, security questions, right? Something you have, phone, hardware tokens, smart card, something you are, like face, voice, stuff like that. Use two or more. Multi-factor authentication is using two or more methods of authentication. Okay. Typical authentication flow: user submits credentials, server validates identity, session or token is issued, user approves identity for future request. Base trust of access. Common authentication vulnerability: weak password policies. Occurs when short password allowed, no rate limiting, no account logout. Leads to brute force attack, credential stuffing. So the main common vulnerability of authentication is weak password policies. And we have credential reuse also. Users reuse password across sites. Yeah. Let's say you have different accounts from different sites. You can use some users. They will use the same password for all these sites. So if an attacker knows the password of one site, he's going to be able to access all. Broken logic. Broken logic is partial credential checks, like logic bypass, incorrect login without valid credentials. Insecure session handling. Session ID may be predictable, like token may not expire. You might have token is what you might have tokens that are valid for a long period of time, and they may not expire easily. Authentication is not finished after login. Missing or weak multi-factor authentication. Token-based authentication issues. Like sometimes long-lived tokens are risky. It has to be short actually. Tokens stored insecurely, and no token rotation. Like you can store it in local storage. Readability misuse is especially common. Password reset or recovery flow. Attacker targets password reset link. Security questions, email verification flow. And authentication versus So basically you need to have a strong password handling. You need to use hash and salt password. Okay, not just hash, also you need to add salt. Salt makes it difficult for hackers to guess password. Enforce length, make the password complex. Rate limit is useful. Rate limit means like login attempts. Let's say after 5 attempts, it's going to block my account. Going to ask me to wait for 10 minutes or something, right? This is the rate limit. Secure session management, regenerate session on login. So you have to have different session for every login. Okay, don't use the same session. Expire sessions. A session has to have an expiration date. Also, when someone logs out, it has to invalidate the session. Multi-factor is important everywhere. It matters. Admin action, password change, financial operations. Secure token design, short token life. The life of a token should be short. It should be stored properly. Scope, limited tokens. Monitor authentication events, failed login patterns, login anomaly, multi-factor bypass attempt. So authentication in real life, teach students this mindset. Attacker asks, can I log in as someone else? Can I stay logged in longer? Can I bypass verification? Can I abuse recovery flow? So all this stuff. So there is one more, but I want us to understand the concept first before moving on to the labs. Okay, about authentications. So authentication is a very important topic. So let me just go here and type authentication. No. So authentication and authorization. We're supposed to have authentication here. Full auth and authentication, next auth, full card. So let's just try to understand authentication properly before moving on. I think we should understand authentication because yeah. So basically, when we talk about authentication, there are few things that we need to understand. And I think we should control F, authentication. So yeah, authentication bypass, path reversal, weak auth. So we have authentication here, and there is one complete notes or JWT. We talked about that. I think it's here. Yeah, this one is going to be deeper, I believe, in terms of information. I think, but this is only about JWT. I think. Session cookies, and there is more actually. I think. 1 second. JWT. JWT, because we have JWT auth flow API security. I think this one I named it API security, but I included most of the things that we need to know about everything. Yeah, I think this is the one. So basically, I think we need to cover this one completely because it's actually useful for us as well. Yeah. So basically, yeah. So we need to just understand exactly what these concepts we are talking about here, and yeah. So we can start with authentication. Authentication is the one that we have to start with because it's the most first. Yeah, before OAuth, I think we should finish the difference we have to learn before the yeah, the API security. Before that, I think we should learn JWT. This one. We should learn the difference between session cookies and JWT. Okay, JWT is an open standard. Okay, RFC 751 for securely transmitting information between parties as a JSON object. Okay, it's just a way to securely transmit information between parties. This is JWT. JWT consists of 3 parts separated by dots. Header contains token type and signing algorithm. Payload contains claims, user data, user and expiration. Signature ensures token integrity. So we have 3 parts in JWT. We have the header, token, and signature. Okay, so header just contains the token type and signing algorithm. Payload contains claim like user data expiration, and signature token integrity. So the JWT is like basically, one second, let me show you what JWT is. So if you type here JWT and image, I'm going to show you the images here. So basically, where is the JWT? Yeah, this is how it looks. Yeah, this is how it actually looks. But this, yeah. So here we have the header, which contains the algorithm type HS256, the type JWT. Payload, we have the sub of the name here, we have IAT. Signature, we have this one. So it's going to be like this basically. It's going to be here. This is the first section. This is how it will look. The header. Okay, this is the second section, the payload, and this in red is the third section, which is the signature. Okay, so that's JWT. So the possible attacks are algorithm confusion or non-algorithm attacks, like accepting token with non-algorithm. Accepting tokens with non-algorithm. So and modifying algorithm to remove signature. Remove signature. Validate algorithm, reject non-algorithm tokens. So this attack, okay, algorithm confusion and non-algorithm attack, the idea is on the first here I told you we have HS2, this is the algorithm, right? We can have multiple types of algorithm, but if we use non here, that means we don't need to use the signature, this last part. Okay, if there is none, if we don't use the signature, then it's not secure. Anyone can modify it, anyone can use it and stuff. That's the idea. So we have algorithm types, JWT algorithm types. Let me show you. We have more than one actually. We have we have here these are the algorithm types: HS256, HS385, 512, this RS256, this is recommended I think, and ES256, this is recommended plus, and this stuff is optional. None is actually no digital signature or mark performed. No signature here. If none means, if we use non-algorithm, it means there is no signature. Okay, that's what it means. Okay, so this is the vulnerability, algorithm confusion. Weak signing keys, like issues, weak default or predictable secrets. Okay, attack, brute force the secret key. Prevention, use strong random secrets. Okay, so we can use weak. If we use a weak secret, basically it's going to be vulnerable to brute force attack, right? Weak signing key. Signature verification bypass, not verifying signature properly. Strips signature or modify payload. Always verify signature on the server side. We have to verify signature. Okay, the third part of the JWT. Then we have information disclosure, storing sensitive data and JWT payload. Decode base 64 to read payload. JWT is encoded, not encrypted. Yeah, so basically JWT is not secure, it's not encrypted. If you store any sensitive information like password inside the JWT payload, okay, it can be decoded by base 64 easily by anyone. Okay, it's just encoded, it's not encrypted. Remember this point. Never store sensitive data in JWT. Use encryption if needed. So we have keyed parameter manipulation. Keyed parameter manipulation is improper validation of key ID header implement parameter. Attack path reversals or SQL injection via keyed parameter. Validate keyed value, avoid file or database in key ID. Okay, so yeah, JWT replay attacks. That means if JWT has no expiration or replay prevention, that means we can reuse the captured valid token and use to prevent this. It is basically replay means reuse. Just get the token and use it again. Okay, to prevent this, you have to use you have to have a short expiration time, and also include JWT ID. Maintain revocation list. Okay, we have one more concept: algorithm switching. Algorithm switching is RS256 and to HS256. So basically, an attacker can just change the algorithm from RS256 if the token is using RS256 to downgrade it to HS256. So you can change asymmetric to symmetric. Okay, he can change it to symmetric because the difference is RS256 is actually asymmetric. It means it uses two keys, public and private. HS26 uses only one key, same key. So he can use it just to make it easy for him to exploit. He can validate algorithm match, prevented validate algorithm match expected time. Yeah, you should also whitelist like this one. You see, it's type algorithm HS26, whitelist algorithm max age 1 hour, short expiration issue validate. So we can set we can validate algorithm match. Like, yeah, and say that this is the type of algorithm that we accept. So token design, it just keeps payload small. Keep payload small. Use expiration time, short-lived tokens. Use IAT issued at for age verification. IAT means like issued at. And consider refresh token pattern. Storage and transmission, use HTTPS only. Web, use HTTP only. Secure, same site cookies. Mobile, use secure storage, keychain. Never store on local storage, vulnerable to XSS. So additional security measure, implement token revocation. Use rate limiting on authentication endpoints. Monitor and log authentication failure, regular security edits. So tools for testing JWT security. We have this. So common vulnerable scenarios to watch for. Development defaults in production, missing signature verification, accepting token from untrusted issuer, no token expiration, and this stuff. Yeah, so we need to also understand, now that we understand JWT, how it works. Okay, also I suggest you go back, you watch one video now in my previous in my channel. I've talked about the JWT there. Okay, I've talked about it, so you should watch that after. Yeah, you should also watch that. And I also did one lab about it. It's actually this one, not this one, this one, JWT hacking. So do the lab, watch the video, and yeah. So let's talk about sessions and cookies. Cookies is small pieces of data stored in user browser, sent on every request to the server. Session is a server-side storage of user data typically linked to cookies via session ID. So, how sessions and cookies work together? User logs in, server creates session ID stored in a cookie, browser sends cookie, server validates session ID and returns the session data. So that's it. So let me give you an example here. Let me use this one itself, this one. So I already logged into DVWA, right? So all I have to go is like go to inspect here and go to application and go to cookie here, go here, and we just got this is the session, this is the cookie. Okay, this is the cookie session, and you can see the cookie, there is a cookie here, right? So you can see here the domain, the path, the session, and you have the size, HTTP only, secure, same size. The difference, if this is set to check, that means that HTTP only means it prevents access, it prevents JavaScript access to the application, client-side JavaScript access to the application. This is for security purpose. Secure means it only allows access to if you're using HTTPS, it doesn't allow HTTP. Okay, same side means prevents cross-site, يعني from SSRF attacks, like it's, yeah. So that's basically it. That's it, and we'll check it one details. So common attacks and vulnerabilities. So just I will repeat this because this is very important, so you can understand how it works. Okay, so when I just logged in to DVWA, what happened? The server creates a session. It created the session. John is logged in, and session ID is stored in a cookie. Okay, this is what the session ID is, what the server uses to identify my session, the session ID. So browser sends the cookie, and the server validates the session ID. The server cares about the session ID, that's it, and returns the session data. Okay, so the common attacks and vulnerabilities, we have session hijacking or fixation. Okay, attacker steals or sets session ID. Okay, and accesses steal cookie via JavaScript. Okay, no. So session hijacking or fixation is just attacker steals set session ID. Okay, and he can use JavaScript cookies for this. He can steal cookies via JavaScript. He can use an encrypted connection attempt. He can force victim to use attacker's session ID. Okay, to prevent it, regenerate session ID after login. Okay, after every login, the session ID has to be regenerated using this command: request session regenerate. Okay, and use secure HTTP only cookies. Okay, HTTP only. Make sure that secure. Make sure that HTTPS is used. Okay, this will prevent second attack, network sniffing. Okay, it will make it difficult for attackers to just capture the session, the cookies. And HTTP only, this will prevent XSS attacks. It will steal, it prevents stealing cookies. It prevents attacker from stealing cookies via JavaScript. Okay, and cross-site request forgery. This is a forged request from malicious sites. Okay, forged request from malicious site. Okay, attacker tricks user into submitting requests with their active sessions. Okay, the attacker will trick users into submitting requests with their active sessions. So the attacker will use your session, your active session, to submit a request. Okay, so you should use a CSRF token. Okay, constant, require CSRF, and you should include token in the form also, like this, and use double submit cookie. Use same site also strict. So just so we know what is CSRF, just so we can understand what is CSRF, so you can just have some idea. So CSRF, so we'll explain for you what it is in the right way. It's a web security vulnerability where attacker tricks victim's browser, exploits the browser, focus here, into performing unwanted state-changing actions such as changing password, transferring funds, or updating email address on a trusted site where a user is already authenticated. So let's say I opened here any bank here. Let's say Bank of whatever, Bank of America or whatever. Any bank here. I opened this one and I logged in and stuff. Okay, and if a browser, okay, just if an attacker just exploits my browser, okay, behavior, he can use to send cookies with requests. He will embed malicious request, example in a hidden form or image tag on a different website that the user visits. Okay, the vulnerability relies on the target's web application trusting requests from user's browser. It will includes authentication cookies. So yeah, so this will he can use this to attack, to perform a request on my behalf using my browser. Okay, my session, my active session. XSS is just malicious script access cookies, steal session cookies via JavaScript, and HTTP only cookies blocks JavaScript access. HTTP only blocks JavaScript access. We have to set it to true, and we have to use also, to prevent XSS, actually we have to use CSP, content security policy. Like this, we can specify here, we can add a policy here, script source, make the source only self, and we can type the trusted URL here. Okay, this will prevent XSS attack. Okay, so security policy. So we can also, this is very important actually, CSP. Okay, CSP is a feature that helps minimize the risk of certain. So computer security used to web development to prevent cross-site scripting, data injection, declaring. So this is it. So it allows site owners to whitelist trusted domains for scripts, images, and other resources. So that's the benefit of CSP. That's why we use CSP. We must use CSP to allow site owners to whitelist trusted domains for scripts, images, and other resources. We will specify here, we trust. I'm saying I trust this page, and I can specify this here. So insecure cookie attributes. The issue is poorly configured cookie flag. Virus attack based on misconfigurations. Let's see, what time is it now? Okay, so we have insecure cookie attributes. We have session prediction. Virus attack based on misconfiguration. Insecure misconfiguration means like this: HTTP only is true, this is okay. Secure is true, it's okay. Same site strict is okay. 15 minutes. Domain path appropriate path. This is the secure configuration. This is how it should be. Okay, so I'm saying basically, don't allow any JavaScript access. Okay, and make sure only HTTPS is used. Make sure we have the same site strict policy. Okay, to prevent CSRF attacks, and make sure we have a limited time, maximum age, which is 15 minutes. Make sure we have a domain here, path, this one. But if you put here false or you put here false, it's not going to work. Session prediction, basically predictable session IDs. We have session IDs, they are predictable. Attacker can guess valid session IDs. Okay, so it's recommended to use cryptographically random session IDs like this. Const crypto, require crypto, and const session ID crypto random by this one. We have session reply attack, reusing captured session ID, and reply all authenticated requests. Reply means reuse. you can use captured session ID. That's why you should actually regenerate the session IDs first of all, and yeah, and you should have a maximum session ID session set 15 minutes, for example. After 15 minutes, you shouldn't be able to use the session ID. This will prevent the attacker from reusing it. So we have man-in-the-middle attack. An attacker can intercept cookies over HTTP. Okay, so unencrypted transmission, they can intercept. So, but what we need to understand about session and cookies is that let me show you what session ID looks like. Session ID. Let me show you what session ID looks like. Basically, this is session ID. Yeah, so this is a session ID. You have session, you have the user ID, device ID, session ID. This is the session ID. Let me show you here. This is the session ID, and so session ID is going to be, yeah, basically that's the session ID. Yeah, here we have it here. This is the session ID. So it's just a combination of numbers and letters, it could be, and that is used by the server to validate the session data and communicate with the client. So it's session ID. So we can have a session ID here. I don't know if we have session ID, so I can show you. So basically this is session IDs, and that's it. So you have to use crypto random it has to be random, make sure it's random and stuff. And best practice for secure session and cookies, use cookie security headers. Yeah, make sure you have we talked about this, you have to use these headers, and make sure we have session management and additional security headers. Yeah, these are important actually. You should add this security headers. This X-frame options, deny, it prevents clickjacking. Clickjacking is just an attack when they put a frame inside a button. You don't see it, but when you click the button, like it is going to exploit your session. So this clickjacking, this XSS protection, okay. MIME sniffing, this content type, you can just put no sniff. Referrer policy, you can use this one. And you should use secure session storage, okay. Avoid memory storage in production. Use external stores, like yeah, you can use Redis. Redis is actually a caching tool, okay. You can use Redis to cache your session storage, to store your session, because this is what it's meant for actually. Redis is like for, since session is not stored for long, it's just for simple time, like you can use it. And authentication flow securely. Yeah, and common vulnerable scenarios. Yeah, some your applications actually put the session inside the URL like this. They put session ID, and they put inside the URL. This is actually vulnerable. Okay. Yeah. Cookie only. Use cookies only. You should use cookies only actually. You should put the session ID inside cookies, not on the URL. And missing secure flags. And sometimes they don't add the secure flags here. If you don't add secure here, it's going to be accessed by HTTP. And logged session timeouts. Okay, this is 30-day session. It's very long. Okay, short session with refresh is the right option. Sensitive data exposure. Store sensitive data in session. And yeah, if you store sensitive data in session, then it's risky. You should only store ID and metadata. So we have yeah, you can attempt session fixation and monitoring and detection. Key differences between JWT and session is that JWT is stored in client side, cookies and local storage. Sessions are on server side. Remember, Sessions are actually stored in the server side. It just uses the session ID on the cookie, so that's to identify the session. Yeah, JWT is stateless and session is stateful. Scalability easier, and this is the difference. Use sessions for most web applications, JWT for API or stateless scenarios where server-side storage isn't visible. Always protect security. What's the main difference between JWT and session? JWT is stateless tokens that contains all user data within themselves, while sessions store user data on the server and use session ID in the cookie to reference it. Remember, session ID in the cookie to references. Why shouldn't you store JWT in local storage? Local storage is a vulnerable XSS attack. If your site has XSS vulnerability, attacker can steal token from local storage. Local storage is this one. This is local storage. This is local storage. Okay. Yeah. What does HTTP only flag do in a cookie? Yeah, we know about that already. What does fixation work? We already talked about. How do you prevent CSRF with sessions? Use CSRF token, implement same site, strict flags, use double submit, verify. Okay, so we have already I think understand most of this stuff already about JWT, cookies and sessions. So I think it's about time now that we move on to the I think we should actually move on to the labs, because I think we now understand how it works. Okay, so yeah, we understand how it works. So this is it actually. So let's do some labs with the let's do this lab. Okay, I'm going to go ahead and do this lab, and I'm going to go here and I'm going to refresh this. Let me close this because there are too many things here and we don't really need it. So just Steam is file closed. Close it, no problem. Let's open the tab here. Let's take a break because I need a break for session, and we'll continue. Yeah, okay, let's go ahead and start our session. Okay, let's read what it's telling us. It's telling us we have it's vulnerable for user enumeration and password brute force attack. It has an account with predictable username and password which can be found the following word list. Okay, no problem. Let's open this on new link. To solve this lab, enumerate valid username and password. No problem. Let me just try to go to the posts and do something, just so we can get something in there. And let's go ahead and try this. I think we need to take. No, let's go to account. I should have some. Yes, but I should be able to. Let me check this one. Let's see what we will get. Let's try to type anything here. It doesn't have to be the correct password or username. Just login. It's invalid username. So we can see the fact that it's invalid. We can go here. Yeah, we have this one, right? We can exploit this one. And let me see. Yeah, when you type here, just we can understand this one. So we can send it to intruder. Intruder is, I think, we haven't gone through it, but intruder is unlike repeater. This is used for brute force attack. Username, password. We can use intruders here. Okay, so what it will do is like, let's say we have here. Let's say we have here. I want to check the username. I can just add here. I want to check the password also. I can just add here. Then it's going to give me the. We can choose attacks here. Sniper attack inserts each payload into each position one at a time using a single payload set. Pitchfork allocate payload set each iterates each set. So let's try sniper. Okay. So I'm supposed to actually try go to the username here. Okay, I'm going to try all these usernames. Let me try all these usernames. Let me copy this one. I will copy this one and I will paste it here. Paste this one. So these are the payloads, and I think that's about it. So, but I should be able to add the second payload also. I think we need to. Yeah, this is one. Okay, and it's the username enumeration. The password. I think we're supposed to use a different one, maybe pitchfork attack. Yeah, simple list. We have two payload positions. Yeah, I think we're supposed to use the username here, this one. The username section, we're supposed to add here the payload for the username, and in the second position, which is this one, second position, this one, we're supposed to add the password, authentication password here, and paste it here. So let's start the pitchfork attack and see what happens. Okay, fine. We just want to check what is the, see what happens here. Basically, it's just trying username and password. Username and password. I think what we are doing wrong is actually discard this one. I think we are adding this one, the first one. The first one actually is not supposed to be there. Clear all. Okay, so I'm just going to put this one, add here, and this is the second one, add here. So we have two payloads now. It's the first payload, Carlos, and the second payload. Let me remove the second payload here. Clear. The first payload, make sure it is actually the username. Let's see what's this. This is actually the password. Let me copy this. Let me add on the second payload, paste it. And on the first payload, we have to put the username. Paste it here, and let's start the attack. Okay. Yeah, this is it. This is the first payload, second payload. So we just need to wait. I don't think it is working properly. Let's see. This might take time actually, but we're supposed to identify this based on the assuming based on the maybe based on the length, or sometimes we can use the response size or the status code. Sometimes you can find a different status code here. You can identify it using the status code, and sometimes you can find different responses saved here. The length, all this will tell you if it is the right one. Okay, but right now it's trying this name and password, and it's checking each one by one. So it is doing that, right? The lab is vulnerable, so yeah. So we're doing this, but let's see. Hello everyone. Now regarding the authentication, we're going to go ahead and do the authentication labs. Let me just this is okay. Let me go ahead and start the lab here. So I'm going to do this lab first, and then I'm going to do this lab, and we'll try to do the first 3 lab, and we'll do this one as well, just so that we can understand how this works, and we'll try to do password reset poisoning as well. So let's go ahead and try this one. Okay, I'm going to open the link here. Let me close this, you don't need it right now, and make sure your web proxy is on. So this is user enumeration via different responses, and let's read here. The lab is vulnerable to username enumeration and password brute force attack. It has the account with the predictable username and password, which can be found in the following words. Solve the enumerate valid username, brute force the user's password, then access their account. Okay, they have given us usernames here and passwords here. Username, yeah. So let's see what happens here. Username, brute force the user's password. Okay, let's do it. Now let's go to HTTP history. Okay, and let's see the yeah, I think I already run it, right? So I should be able to select as and let's see what we need. Yeah, I think we are supposed to test the login account user enumeration, so we can try anything here for now. I think it doesn't matter actually the name. You can use test here, and just type here test. I just want to see the response here. It says invalid username, so this actually is a very wrong way of checking. Basically it's telling me this way I can know that if the username that I'm writing is correct or not. Okay, it's telling me that invalid username. If I put the right username here and I put the wrong password, it's going to tell me invalid password. this is actually giving hint to the attacker which one of this is wrong, username or password. This is very bad way of doing things. Okay, your the errors should be generic. It should say invalid username or password. Okay, you should not, the application should not disclose whether the username is wrong or the password. Okay, it should not be disclosed here. So this is the vulnerability that we are going to exploit now. Let's check the login file here. Let me send it to repeater, and from here let me put this down. Yeah, this is the username. I'm going to send it to intruder. Intruder is used for brute force attack. I'm going to choose username here, add it here. First we are going to focus on the username just to make sure that we are getting the correct username. I'm going to copy this one from the word list here. I'm going to copy this and I'm going to paste it here on the word list, and then I'm just going to use sniper attack, which is enough, I think. So let's start the attack. Okay, let's give it some time, and yeah, let's do the attack. Okay, I think we can identify this based on the response length, I think, from here. Yeah, because yeah, it will be different, right? If it is password, if it is user, then there will be a difference in the length of the response, right? So let's just wait for it to finish. Actually, this might take so much time, so I'm just going to pause this. And yeah, so it finished. So now that it finished, we can just put this down and see at the top here. It's saying, do you see this one? If you notice, this one is different, the length. Okay, this is 48, this is 50. So that means if you notice here, the response here for this one, you're going to notice the incorrect password. You see this one? It didn't say incorrect username, it says incorrect password. That means the username is actually correct, Alaska. So all we have to do now that we know the username is Alaska, you just have to cancel this one, discard. You just change this one, the username, to Alaska, and now we try to do for the password. We go to the word list, and we're going to use here, and we're going to just paste this one and start the attack. Yeah, start the attack. Now it's going to start to check the password with the username Alaska. So we can actually just pause the recording so that it doesn't take. Okay, so now we can go ahead and check the password. Again, the password, we are going to check it by yeah, I think we can check the status code here. You see the status code, you can check the length. Sometimes the status code is also helpful. You can check, you see something different, you can use this one. You see if there is something different. You see 302 here, so this must be the password. Also you can see in the length also it's different than all, so this must be the password. To verify, you can just correct here saying 302. So we successfully got this one. Go to request. So all we have to do is just copy this one and try Alaska, and we are going to be able to solve the lab. So we successfully solved the lab here. We can try here Alaska, and we can just paste the password here, and we have access to the lab. We've solved the lab. So basically this is how we can do brute force username and password, username enumeration via different responses. So next lab in the authentication section, we have let's control F, authentication. Authentication. We have this one, 2FA's multi-factor authentication. Bypass. This lab has two-factor authentication, can be bypassed. You have already obtained a valid username and password, but do not have access to the user's two-factor verification. Solve the lab, access Carlos account. We're using this credential, and this is the victim credentials. So the idea is can be bypassed. So we have two-factor authentication on Carlos user. Okay, you have already obtained a valid username and password, but we don't have the access to the two verification code. It will be sent to his mobile or something. So what will we do? There is a way to bypass this one. Okay, we should be able to access Carlos' account. Bypass this two. Let's go ahead and try it out. Let's go ahead and try this out. Okay, so we are going to go ahead and do the we're going to go ahead and go to accounts. We're supposed to log in by let me show you how it works first. Weiner and Peter, this is our account. Let's try to log in here using Weiner and Peter. See how it works. Login. So we have 4-digit security code. Since this is my account, you can just open the email client here. I'm supposed to receive the 4-digit security code here. So view the code. This must be the code. So I just copy this one and paste it here. Login. Okay. I think the issue is there was space at the beginning. That's why this happened. Let me log in. Let me just go to the. I think this one is expired already. Let me just refresh this one. Refresh the client. So this is the password. 1082. So type here 1082. Yeah, let's log in. Done. So we already logged in. We were able to log in, right? This is how it works. So now what we need actually is to try to log in using the victim's credentials. Okay, see if we can bypass that one. We can just go here and type Montaya here. Paste this one, login. So now we're not going to receive the security code because this is not actually our account, okay? But we can bypass it by just let's go ahead and check first of all, see what happens, how it works. And if you go down here, we have login here. We have login here, and let me send this one to repeater. This is for Carlos Montaya. Okay. Let's login too. Let me send this to. I don't think we need this actually. Just need the login. No, the bypass. Yeah. This is my account. Okay. So send this to repeater, and yeah. Let's see what happens here. Okay, this is my account, and I can just use this link, for example, to go to my accounts. I can just change this login to and paste this one. I can access. Done. We've solved the lab. So you see what we did here? We were able to bypass the OTP, the 2FA authentication, just by changing the path to the my accounts page. So now we don't have to go through the OTP. We just have access to the application. So this is basically how 2FA works. And let's do this one, the third one, and we can just do this one, third one here. Okay. So the lab password reset functionality is vulnerable. To solve the lab, reset Carlos password, then log in and access. This is my account page. Okay, I'm supposed to reset Carlos's password. So let me try to use my own to see how it works. I'm just going to go here, type Weiner, and I'm going to type here Peter, and I'm going to log in, and I'm going to check the email client here. The inbox is empty because I'm trying to reset. I'm supposed to type the email, so let me type my email here. This is my email, I think. So let me type my email here. This is to update an email, or no, we need to reset the password actually. So let's go to accounts and see what happens. Yeah. Okay, let's go here. Let's go to my account. Password reset, broken logic. Okay, let's update our email and see what happens. Okay, the email is updated. Then what? No, let's just log in again. This is the one. So we can just click forget password and type our email here. Okay, then submit it. Okay, I'm supposed to receive the password reset token here. Okay, the link. So I just have to click this one and type any password here. I need here new password, which is, and this is my submit. So I change the password here. Change the password here. So let's see what's going on, what happens in the request response. body here. Okay, I'm assuming this one. Let's send this to repeater. This one, send it to repeater. Email, I don't think we need it. Forget password, we might need it. And forget password, we might need it. Let's go ahead here and check one by one. So this is just forget password, text the username, which is basically the email, and this is not what we need. And this one, this is where things is happening actually. Yeah, and we are actually doing it here on this level. So here we have temporary token here. Okay, here we have temporary password token, and this is the temporary password token, and this is the temporary token password. So what we want to check is that we want to check whether this application is actually just comparing this token with this one. Like if it's just, yeah, making sure that this two has to be same, or is it actually validating the token? Yeah. So we can just put anything here, put X here, and remove this, put X here. Okay, and we can change. We can just send and see what happens. Still, it worked, even though we can change. So it's just making sure that both are same. It doesn't matter what you type here. So if that's the case, all we have to do is just change the name here to Carlos, and Carlos will have the same username and password as done. So now the lab will be solved. You can just go to my account and you can type Carlos here, and because we've changed lab, we logged in and the lab will be solved. But this is the idea of password reset broken logic. Okay, sometimes they just don't check properly the token, so that's why I was able to do this. And this one we should do, I believe. So we will try one more lab, and that's let's do this one. Password broken password protection IP block. Okay. This lab is vulnerable due to practice logic flow in its password brute force protection. Solve the lab, brute force the victim's password, then log in to access page. And its password brute force protection. To solve the lab, brute force the victim's password, then log in to access their account. So your credential is this one, victim is this is the candidate password. So okay, we just need to check, see how it works, and see, yeah, try to get Carlos' password. So brute force attack is just a matter of when you do multiple attacks at one, when you try different username and password here. Let's say I put Carlos here, or Weiner, or whatever. Yeah, you can try one, put any password here, just see what happens. Incorrect password. Let's try again. Incorrect password. Let's try again. Incorrect password. Let's try again. Not the same. Incorrect password. So this is what we got. You have made too many incorrect login attempts. Let's try again in 1 minute. Okay. So now if I put anything, I can't. Even if I put the right password now, Still, I'm sure I can do it. I won't be able to do. I have to wait 1 minute. Okay, this is brute force because I've attempted three times. I think 3. Yes, after 3 attempts, it's going to block the IP. So, what's the solution for this one? There is a way we can bypass this actually. Since we know that it's doing this after 3 attempts, what we can do is we can put the wrong password, the correct password first, and then try the wrong password, and do the correct password and try the wrong password. Correct password, like we can alternate, different passwords. But after 1 attempt, we should try this the correct password, so it doesn't block. Let me show you. Okay, I'm going to use this one. Okay, okay. So what we will do is, since what we need is we have one, we know that Weiner is the correct username, right? Carlos is the victim's username. So we just alternate it. This is the word list 100 times like this. Okay, and then in the Peter's case, in the password list, we put Peter. This is the correct username of the Weiner user, so it will be successful. First attempt. Second attempt, maybe this is correct, maybe not. It will, even if it's not, it's fine. It will fail. Okay, and then after that, the correct Peter. So again, we're resetting the counter. Because this brute force it has a counter 3. So before it reaches 3, we are putting the correct username and password, so that it can reset the counter. It can start from 0 again. Then we put like this. We alternate. Put correct, wrong, correct, wrong. We keep alternating this way, so in order to reset the counter. Okay, and then we can solve this lab. Okay, but I'm not sure if we can do it in Pursuit Community Edition for this, but we can try, no problem. Let's go ahead and try this one. We can just go here and send this to repeater. Actually, intruder, not repeater. Go to intruder, and we're going to use pitchfork and we will target 2 payloads, 2 positions. We'll target Weiner, add, and we'll target Peter as well, and we are going to paste it here. Okay, we're just going to copy this one. Peter, this Peter just. So what we will do is just paste this one, start an attack. It's going to try this one, it's going to try this one as well. Try this too. And yeah, so we can start an attack here. No, before doing this, actually we should do one thing. I forgot to do it here. Continue attack in the background, discard this attack. You should set the resource pool to create in the maximum concurrent request has to be 1, so it will do test 1 only, 1 by 1. Start the attack. Just give it some time. Yeah, see how it's working? It's checking the first. This is correct, this is wrong, this is correct, wrong, correct, wrong. Let's see what happens. So we are setting the counter for the brute force by putting the correct password every 2 attempts, every 1 attempt. So just wait, let it finish, and we'll pause this video. Yeah, so we just finished the lab, and we can see. Okay, here's what we should do. Actually, we should filter by the There is a way to filter here. We can filter the, we don't care about the 200 obviously, but let me see if there is a better way to filter this one. Show all items. We don't want 200, we want the 302s only. And show only items with not only highlighted. This is disabled actually because this is pro only, so we cannot. Just let's apply this one, so it will only display for me the 302s. Okay, so, and I don't need the whiners. Okay, that's why I filtered here. So I got here Carlos ASDFG, so this must be a successful login. Let's check it here. Successful. So ASDFG H. Let's try it out. Let's try it out here. Where is it? Assuming it is inside the here. So Carlos ASDFGH login, and we have solved the lab. Yes, we've solved the lab, so we were able to prove